Good afternoon, and welcome to Likeable Science, broadcasting here from the ThinkTech studios in Pioneer Plaza. I'm your host, Ethan Allen, and we're talking about, today, we're going to talk about glass. Now, you might say, what does glass have to do with Likeable Science? But hey, we all like things in glass. We all drink wine out of glass bottles, or Coke out of glass bottles, or something. We all have food out of glass jars. There's a lot of glass around in this island. There are, something like 55 million glass containers come into the islands every year. So that's really just a little piece of the glass. Anyhow, we're going to talk about that on Likeable Science today. And to discuss this, I have Kevin Gooding back with me here today. Welcome again.
Thank you.
Kevin's a hydrologist, geologist from OceanIt. He's a member of he's a certified professional geologist with the American Institute for Professional Geologists. He's worked for the state and the city, or the state and the county, I guess, before being currently at OceanIt, and for last, I guess, 3 or 4 years, 5 years, 6 years, something like that.
Something like that, 7 years now.
7 years now, okay, going on. And got his Master of Science back at Colorado State. Anyhow, we talked before about groundwater, which is, of course, something Kevin obviously knows a bunch about, but while we had been having some conversations about groundwater, Kevin was telling me about the issues of glass recycling, and I had sort of naively assumed this was a pretty simple process. Hey, you got a bunch of glass, you sort of crush it up and grind it down into sand, and we always need more sand on these islands. I thought it was just a simple thing. But as many simple issues are, it isn't simple, is it?
It's not simple at all between collecting it and cleaning it and actually turning it into a product. It's costly.
Yeah, that was something I read a report that I guess you were a contributor, at least, to this report, if not the primary author. I don't know your exact role in it. But it talked about the 8 or 10, 12 different kinds of factors about the glass, about what the market for it is, what the industry and public resistance is, how much of it you produce versus how much can be used. All these different factors that you have to begin to think about and somehow balance against each other. But let's maybe start at the base here. There are really fundamentally 2 different kinds of glass that you think about here, really, in the islands, right?
Well, there's, for the most part, there's one type of commodity glass, which is called soda lime glass, which is all the soda bottles, beer bottles, wine bottles, mayonnaise jars, and lots of other kinds of containers.
Okay.
It's all just soda lime glass.
Right.
But it's run through 2 different laws in Hawaii.
Right. This is and this is part of the complication, right?
It complicates things a lot.
So,
yeah.
so without complicating it too much, tell us about these 2 different lines or laws or streams.
Well, we have what most people know as the high five law.
Okay.
But in the jargon is called the DBC law.
Okay.
I'll call it high five. I think it's simpler.
Deposit beverage container or something,
Yeah.
right? Yes.
And the high five law is for mostly beverage containers, which comes out to soda and beer, essentially, and some miscellaneous juice bottles. And the high five also covers plastic and aluminum as well, of course.
Okay.
And that, the number is maybe approximately 35,000 tons of glass a year. I don't recall the number of containers. That's high five. But we were actually tasked with doing a study on another kind called ADF, Advanced Disposal Fee, another law or way of managing glass.
So, and that includes?
Wine, mainly wine and various food containers.
Okay, and so that's basically any jars or bottles that you're not paying that 5-cent deposit on are more or less this other category.
Exactly, everything else,
right.
Yeah.
And they're called advanced deposit
disposal.
Because the manufacturer pays some small fee in advance, right?
Yeah, when they ship it into Hawaii, they have to pay 1.5 pennies per container.
Okay, right, but that doesn't begin to cover the costs.
That was a number that was calculated back in the early 90s. It probably worked back then, maybe, but it doesn't now. It doesn't cover the cost of disposing of that bottle.
Right, so we're left with the fact that this whole process of getting rid of this stuff, and it's not a trivial problem, right? I mean, there are, we said something like 55 million of these containers come in each year. Obviously, if you can't just like hurl these into a big pile somewhere, because pretty rapidly you're going to have a pile bigger than the island.
Exactly, yeah.
And that wouldn't do it all. It'd be unsightly to say the least. But so what do we mainly do with this at this point? I was sort of surprised to hear this.
Well, for what we call the ADF glass, only 46% of it statewide is actually retrieved for some sort of recycling or downcycling. The rest, you could call it unaccounted for, but probably ends up in the landfill or as litter.
Wow.
For the most part.
So we have a graphic up here that shows the types of recycling.
Well, we were given a job to kind of identify a solution to the ADF glass problem, something you could use it for. And we obviously gravitated towards reports, and we wanted to document everything, but there was no reports available. So really what we did is we interviewed many different people, stakeholders, users of glass. And the first thing we identified, one of the early things, was that people use different terms.
Yes, right. People don't understand the language in the way that we do.
And so we found generally accepted terms, and there is reuse. That's the best thing to do with a bottle.
Right.
You don't melt it, you don't crush it, you use it as a bottle again.
Right, it's very energy efficient, right? All you're doing is you have to just basically clean it.
But that's not done very often. It can't be done. It's very difficult to do in Hawaii because we don't have much bottling here, little or none.
But why is this? I don't really understand, because this used to be something that was very commonly done. Every local dairy did it, right? They would send milk out in bottles, and then you leave your empties back out there. They pick them up, they take them out, they clean them, they'd reuse those. And so it used to be a very common practice. What has made it so expensive?
No, I don't really have the reason I have that. It's something I've always been interested in. I think a lot of it is expediency. We just don't want to deal with things.
Huh.
Throwing it in the trash, or nowadays the blue bin, hopefully, is much easier than rinsing, sorting, because we'd have to do all that at our house. Soda bottles, beer bottles, milk bottles, wine bottles. I think.
Yeah, okay.
But we may need to do it in the future. I believe we will.
Sure, sure. Okay, so there's the reuse, but for various economic reasons, that's not being really pursued very heavily. So next on the list is then?
Recycle.
Okay.
And that's basically to melt the glass and turn it into another glass product.
Okay.
Generally another bottle or container, but fiberglass and other more obscure glass products also.
Right, so again, as long as you're using more or less the same kind of glass, you can probably do this okay, and everything will go smoothly. And it's obviously more expensive. There's a huge amount of energy involved in melting it down, reforming into bottles, but it's certainly a feasible option, and it makes good use of the materials, right?
It's a very feasible option if you're near a plant that does it.
Right. But the issue with the recycling in that sense is you've got to have a facility that can handle a lot of glass on a very continuing stream, right? Because you've got a big melt pot there, right?
And that melt pot doesn't shut down.
Right, because if it shuts down, you have a huge
Solid.
chunk of glass.
Yeah, exactly.
That's going to be very difficult to start melting again.
Yes.
And, yeah, so you have to keep it running 24/7, basically 7 days a week, year round. And it's probably got to be done on a fairly good scale to make that feasible. And oddly enough, 55 million bottles a year isn't a big enough scale, right, to make that work.
Yeah, 55 million bottles sounds like a lot. It's 23,000 tons.
Right.
That's not much.
Wow. Yeah, I mean, that's a couple thousand tons a week. You would think you could have a facility, but apparently not, huh?
Yeah, apparently these are big facilities, and our glass for recycling is shipped to Oakland, California.
Right, so this is amazing to me, but again, I mean, it seems to fit with the way we do so many things in this island. We import a bunch of our food, and we export a bunch of stuff that we grow, and it turns out then we import all these bottles, and we export them all back out. And again, it seems like it costs, I mean, it's huge shipping costs. It's $120 a ton or something.
$120 a ton to ship it back.
Yeah. Whew. I mean, that's...
And then glass is not a high-value commodity either. There's various prices. Maybe about $5 a ton is what they'll pay.
Right. So
at the dock in Oakland.
So this means the state basically, and ultimately the consumers, are paying $115 a ton for this glass times 23,000 tons per year or whatever.
This basically, the
not
state
pocket change.
collects money from the ADF fee and distributes it to the counties. And the counties are the one on the day-to-day have to get rid of our rubbish. They just have to. And so they're really the ones who pay for it.
Wow.
I mean, which is us, the taxpayers.
Right, right. So, and the problem comes in because of, again, these two different streams. You can't bulk the whole thing up. You can't now take the DVC glass and dump it in with the ADF glass and double the amount and begin to get some economy of scale going, right?
We can't do that because they're two different laws.
Right.
And the money is allocated in different ways and distributed in different ways. And so they're legally different materials. And
seems peculiar.
but as one person told me, if a high five, or they call it DVC container, breaks, it turns into an ADF container.
Isn't that amazing?
Because you don't know what it is then. It's just a pile of glass.
Yeah. It's just like the calories leaking out of the cookies when you break the cookie in half. Yeah. Okay. So a whole bunch of this then, basically, you're saying is probably should be fixed on the policy law level rather than trying to fix it on a technical level in some sense.
Yeah, if we combine the two streams of commodities,
right,
then we'd have more to deal with and more options of where to put it.
Right, right.
And I'm not necessarily against recycling. Maybe it is best to send it all to the mainland. Mm-hmm. But there's other options.
Right, right. And so, the state is then spending something close to $1 million a year, basically, for this process.
They're collecting close to $1 million, about 800 something thousand.
Okay.
The counties are probably spending over double that amount.
Okay. Right.
To actually
so a net.
To do something with this.
Right. So there's a net loss in this process ultimately.
Yeah.
So there's sort of more things you could do beyond the ideal of reuse, and the next good thing of recycle is you use a term called downcycling.
Downcycling is to use it for another purpose of lesser value.
Okay.
And one example, crushed glass, I should say pulverized glass, is essentially gravel. Mm-hmm. And pulverized glass, I want to stress, you can go to the pile and stick your hand in mm-hmm. and go like this and crunch it up. You don't get cut. Uh-huh. It's like gravel.
Right, right. Indeed, I mean, the sand on our beach, basically, you take that sand, you can melt it into glass, and thus, clearly, glass can be converted back to a material that is relatively innocuous to you.
And that's with a machine that's designed to do this job. It's not
right. You don't
hitting it with a hammer or something. Then you'll end up with sharp pieces.
Right. Got to keep hitting it again and again and again. A long time, a lot of hammers.
Yeah.
Tedious process. Yeah, I see full employment laws here.
Handmade.
Handmade sand, from Hawaii. I like it. But there are lots of other things besides just turning it into sort of gravel, right? I mean, I guess I should say this gravel can be used for a lot of different purposes, right? I mean, you could use it, and it is being used in some cases, I guess, on golf courses as a ground cover. You can mix it in with other things and make it as part of asphalt. You could, in theory, use it on beaches, which was what we sort of started this whole conversation about, was models to beaches. You can make it a medium to blast stuff with for sandblasting. You can use it as a filtering agent. I mean, there's a bunch of things, and you helped do this study that looked at all these kinds of options, right?
Yeah, our job was to try to identify something that would solve the problem in the short term, mm-hmm. within the next 2 years, to use this glass. Unfortunately, we weren't able to come across a magic bullet. Uh-huh. It would be a variety of things, and it would have to be subsidized. Because, for example, a rough value of an average poorly sorted gravel would be, let's say, is about $20 a ton. If you go to the quarry and take a big truck and buy it in bulk. Mm-hmm. But to even make crushed glass is well over $100 a ton.
Huh,
so no one's going to buy it.
Right.
Not at that price when you can get it for 20.
Right.
So it has to be subsidized.
Yeah, yeah. And so that, of course, then leads us sort of down into that bottom category on your chart there of garbage. I mean, people just, for various reasons, laziness, lack of knowledge, whatever, toss glass containers to the side of the road, throw them in with their other garbage. They end up in landfills. They end up littering the landscape. And that's obviously less than ideal in lots and lots of different ways. I mean, it's unsightly, it's unsanitary, it's potentially dangerous, these glass bottles, and break and do leave shards all over the sliced tires, slice people's feet.
In addition, all of it that goes to the landfills is filling our landfills.
Right.
And our landfills themselves are, just the tipping fee average, let's say, is about $80 a ton.
Right.
And that's probably not the whole cost of the landfill.
Right.
There's other costs, and there's also what you could call hidden costs affecting property values. Landfills are really expensive, and they don't stop.
Right.
Once you finish, once you fill it,
Right.
it has to be taken care of.
Right. Maintained, actually.
Almost indefinitely.
Right. Right. So I mean, it's very odd. There are no, as you sort of said, that there are no silver bullets to this whole thing. It's going to, one way or another, we bring this stuff on in. We've got to deal with it in some way. And,
yeah.
And either make it a nice home here, or ship it back out and pay. And either one of those is going to cost us something.
And I think we should make it a nice home for it here of some sort.
Right, because that gets us sort of back to this main thrust that we wanted to talk about initially was we have this other ongoing problem that the beaches, a number of beaches in Hawaii, are disappearing. They're being washed away under current ocean conditions, if you excuse the small pun. Very severely in some places along the North Shore, but certainly along Waikiki too. They are losing sand off their beaches big time. And again, it just sort of seems on the face of it obvious. Well, great, we've got all this glass here that we need to do something with. Let's pulverize it into roughly sand and start replacing some of it. Because otherwise we have dug sand out of pits here, except that's getting more and more expensive and less of it available. We sometimes, I think, have brought sand in from places like Australia.
I've heard that too.
Yeah, which again is dangerous because you end up transporting microorganisms around and all kinds of reasons you don't want to do that. So step us through the process then of what would be involved in really producing essentially a usable sand from a bunch of bottles.
Usable sand. Well, it needs to be, we start from the home, the blue bin, for example. People throw a combination of various materials, aluminum, glass, paper, and plastic into the blue bin.
Right.
Then it goes to something people call a MRF, a material recovery facility, which is basically like what you call a de-assembly line. People just sort, it's a sorting line.
Right.
Either by machine, in some cases by machines, but often by hand.
Right. Everything
is separated. And so then you get glass.
Right. And I'll tell you what, we're going to stop here and when we come back, we're going to go into what happens to that glass then once that happens. But we've got to take a break at this point. I'm Ethan Allen, your host on Likeable Science. With me today is Kevin Gooding from OceanIt. We're talking about beaches from bottles. We'll be right back.
Hi, aloha. My name is Chris Leatham, and I host a show called The Economy and You. The show plays every Wednesday at noon, and on my show, I bring on guests who are interested or working in the technology space. And so I'd like you to come and watch the show and learn with me about all the sort of exciting things that we're doing in Hawaii to build and grow our economy ecosystem. So I'd like to say aloha, and I look forward to seeing you on the show. Thank you.
Aloha, I'm Hunter Hevelin, host of Sustainable Hawaii here at ThinkTech Hawaii. You can tune in every week on Thursday at 2 p.m. to see interviews with sustainability professionals from around the state and even further abroad, learning about activities with water management, food security, waste management, and a whole host of other fascinating opportunities to get engaged with making a greener island. So if you're interested in making the transition from consuming individuals to communities of producers, check us out every Thursday.
And you're back here on Likeable Science. I'm your host, Ethan Allen. You've joined us here on ThinkTech Hawaii. And today on Likeable Science, we're talking about a big issue of recycling glass. What do we do with the 55 million glass containers that we get every year into the state? How do we deal with this? Who pays for it? What happens? So in our last segment, we were talking about sort of the initial steps from the home. Yes, you toss them into your recycling. Somebody takes that recycling away, sorts the plastics, the metals, the cardboards, everything away from it. And you end up with glass. Now, you've got to do something with that glass. Now, presumably then, there must be that sorting those two streams, right?
The two streams, I missed that one. At some point, this point or earlier, those two streams have to be sorted,
Right.
DBC and ADF glass.
Right, a lot of the deposit stuff presumably has gotten out before this because somebody wants those 5 senses.
They probably took it in
Right.
themselves.
Right, some homeless person or whatever, or responsible homeowners or small child or whatever, has already cleaned that out. But if not, it gets picked up now.
And then it's separated, and the ADF glass has to be sorted. And all dirty glass is not usable, it's unsanitary. So if it's like an unrinsed mayonnaise jar, it goes into the trash, over their shoulder into the trash can. So
But you're telling me like as we're seeing here, this stuff on the image is just, they literally, the recycling facilities actually just throw the dirty glass away?
they have to. You can't take the time to hand wash a mayonnaise jar.
Oh, no, I envision a giant dishwasher, a dishwasher, 100 feet by 100 feet by 100 feet, where you would, steam, rinse.
Well, if they had, I don't recall the term, but they have a special term, but they have special special lines for cleaning glass that are actually used in some large cities. There isn't one in Hawaii.
Really? That's amazing to me. That would just strike me as something you would expect. Yes, no, people aren't going to clean the glass well, so if you want, you maybe break it up a bit first, but then take your broken glass that's now all in shards and blow steaming hot water over it, and
That would be one way to do it. Yeah.
get rid of a bunch of crud off of it.
But for that picture we just saw a little bit ago, you just saw piles of glass, and
Right.
that was actually, and mostly that was crushed glass.
Right.
Oh yes, on the picture on the right, on the far right is glass that's been crushed into something useful.
Okay.
Towards the left, it's more, it's just bottles.
Right. Yeah. That you probably wouldn't want to stick your hand into.
Yeah, you would not
Right.
want to see your hand. But these pictures were actually taken at facilities, and this glass was mostly for recycling,
Okay.
just to load into a container and ship to the mainland.
Mm-hmm.
But back to what we were talking about, the process.
Right. So and then you've got this pile of glass there.
Then it's once they sort it, it can go into a machine, a crushing machine, and there's various brands. We looked at one machine called Andela. I believe it's from New York. It's a common machine for pulverizing glass. So bottles, broken glass, and a certain amount of contaminants, which there always is, lids, metal collars, and definitely labels can go into this machine.
Mm-hmm.
And it's crushed and to a certain extent sorted.
Okay.
Lids, and most of the lids and things come out one end.
Right.
And a lot of the labels do as well.
Really? Okay.
So then you get what's called, at this point you get maybe, let's say call it about a ½ minus, which is about ½ inch pieces of glass, which aren't too sharp or less.
Okay.
Then they feed it back in to get 3/8 minus,
Okay.
because usually that's what you want.
And they presumably at that point are tumbling it or grinding it in some sense.
The machine is more a tumbler with hammers.
Okay. But it's taking off all the sharp shards and things are all being snapped off by some repeated impact, fracturing, friction processes, right?
Exactly, yes.
Yeah.
It's some mechanism in there really removes it.
So what you end up with then is this, what you referred to earlier, as basically this fine gravel-like stuff, 3/8 inch and less, that's basically pretty benign. You can stick your hand right into it. You can toss it around. You can let your kids play with it,
You could.
Yeah.
But it has, at this point, it still has sugar, little bits of label,
Right.
and little bits of plastic in it.
Right.
And so it might not quite be suitable for a beach yet.
Well, but I mean, realistically, how many of our beaches don't have those things on them, in them or on them now?
That is true, and maybe that's a problem that we as all the stakeholders and as a society need to work out.
Yeah, I mean, I was recently reading this report where people did ocean floor sampling all around the world, North Atlantic, Equatorial Atlantic, Mediterranean, South Atlantic, down around Africa, Pacific, and every place they did, they found a great amount of at least plastic in the ocean floor. I mean, little polyester threads, little microbeads, this, that, and the other thing that are getting there. So, I mean, realistically, we probably have very little pristine sand around, right?
That's a good point, yeah.
So, what are a few labels,
Might be, especially the labels, they will decay.
Right. And So, and I guess they've done a bit of this with I don't know if it's been done here in Hawaii. Has any of it really been done?
Well, as far as we know, deliberate beach nourishment with glass has never been done anywhere in the world.
Really?
There may be a place in the Dutch West Indies where it's said to have been done.
Okay. But you wouldn't find any
We haven't confirmed it.
real evidence.
So that's a major drawback.
Right.
Florida studied it a lot.
Right. I recall when I grew up in Florida, and I recall actually at the time they were even talking about it, and about actually sorting the glass according to colors. They could make different colored beaches. They envisioned having, brown sand, green sand,
that would
white
be
sand,
fun, yeah. That would be lots
sort
of
of big
fun.
stripes down the beach, these different colors. And I thought it sounded like a cute idea. But I guess here in Hawaii, we actually do have sort of an odd sort of natural experiment, right? There was a beach where that apparently was used quite a bit for glass dumping. And people dumped bottles and bottles and bottles for generations onto some beach. And gradually, those bottles have been ground up.
Yeah, that's near Port Allen on Kauai.
Okay.
It's called Glass Beach, of course.
Right.
It's a very small beach, right next to the port. I guess that would be on the north side of the fuel tanks, if you've ever been there. And it is very glassy. And it doesn't seem to cause a problem.
Right.
But that doesn't mean that it hasn't caused a problem in the long past. So if we were to try this again, we'd want to do it in a controlled place with a certain amount of glass and then monitor.
Sure, because you don't want to be hurting the ocean life or whatever, putting people at risk for anything.
Yeah, exactly. We wouldn't want to put people at risk for getting cut, for example, or to certain creatures burrow in sand, and maybe they can't burrow in glass.
Right.
We're not really sure. Or another thing we need to check on is glass is harder than coral. Is it more abrasive? Will it actually abrade things? I don't believe so. I have a rock tumbler, and I load it up with glass and coral. And coral seems amazingly resistant to tumbling.
Interesting.
The glass would smooth.
Really?
The coral didn't. I mean, this is just it's not a very controlled experiment, but I wonder if there's things about the structure of coral, which is just a calcium carbonate, a mineral called aragonite, that makes it more resistant to abrasion.
Right, but our beaches here are actually, of course, a funny mix of things, right? I mean, yes, a lot of the sand is essentially coral that has been, a lot of it actually been chewed up by fish that nibble at the coral. I mean, that was something that I heard years ago that was just sort of blew my mind. So much of our beaches have been produced by this pass-through fish, basically.
Fish, people like to say fish, but of course you can't forget all the little invertebrates.
Right.
They produce much more. Sea urchins, sponges, little worms, they produce a lot. But sea creatures, let's call them.
Okay.
But we do see the parrotfish.
Right.
They're obviously producing.
Right. But there's also then other materials in the beaches because, I mean, from the volcanoes that initially produced the islands here, and it's been eroded off the highlands and run down and it's become part of the sand on the beach too. So
a small percentage from there, and a lot from mechanical erosion of coral.
Right.
Just things bumping against the coral and knocking off pieces. You can see that if you go body surfing at Sandy's. There's everywhere from rocks under your feet to sand, and it's all just wearing out and bumping into each other and turning into sand.
Super. This is interesting, and I want to now go off to explore sort of some of these other uses in a little more depth here, and we're going to do that right after we take a little bit of a break. We are here on Likeable Science. Kevin Gooding, and I'm your host, Ethan Allen, and we're talking about beaches from bottles, all the issues around glass recycling. We'll be right back.
Okay, I'm Jay Fidel, that's Ray Starling. We co-host a show called Hawaii, the State of Clean Energy, every Wednesday, 4 to 5 p.m. It's really interesting. You know, Ray has a way of unzipping these guys. He asks them these questions and all this stuff tumbles out, and we find out stuff we would never know about without Ray's questions. Thank you, Ray.
You're welcome, Jay. I'm very pleased to be your Ed McMahon every Wednesday at 4 o'clock here on the internet. So you can join us and see what's happening in the energy world, and there is a lot going on. So join us every Wednesday at 4 o'clock.
Yeah, come around, be energized, right here on ThinkTech. Aloha.
Aloha, my name is Paul Jackson, better known as PJ. and my local interest is in sports. I have my own sports radio show at KWAI AM 1080 that you can stream live. I also have my own website, pjsportsradio.com. We have live guests in studio, and we talk about discussions and topics that everyone wants to know locally here on the islands. We cover everything from surfing to basketball to whatever's going on locally, sports-wise. We try to do our best and cover the topics in depth as much as we can. Once again, thank you for joining PJ here on Hawaii Sports Update. Mahalo.
And you're back here on Likeable Science. I'm your host, Ethan Allen, here on ThinkTech Hawaii. With me today in the ThinkTech studios is Kevin Gooding from OceanIt, hydrologist, geologist extraordinaire, and we're talking about issues around recycling glass. And Kevin and I had started talking, you may recall he was on Likeable Science some weeks ago, and we had talking groundwater and all, and just in a casual conversation, we started talking about other related sort of geological issues and got onto the whole thing of what do you do with all the glass? And I naively said to him, well, we should just turn it into beaches. We need beaches here, you know. We're always, Waikiki, just a couple of years ago, trucked in a gazillion truckloads of sand to build a beach, and it's, as you were saying, not a natural beach anyways, really, right? It's more or less engineered artificially now.
It was a very narrow beach in front of a wetland in 1910. Huh. And then once tourism started, they had to build it, bring in glass. Bring in sand, excuse me. Quite a bit from Molokai and various parts of Oahu.
Right. So it's just, it's amazing. But this whole business, so in your report that you did, you guys identified just, a dozen different things from the cost analysis, the potential demand, health and safety, environmental impacts, laws, regulations, policies, specifications, testing, industry and public resistance, applications that have been market development, stakeholder complexity. All these factors you have to take into account in just getting rid of a bottle.
Well, getting the feasibility of getting rid of a bottle. Right. All these factors.
Right, play in. And it's stunningly complex. But there are now a whole bunch of options that you also looked at, right? In addition to sort of what you formerly, and I love the term beach nourishment. I think that's a great term, you know.
We have to have healthy beaches.
Right, yeah, exactly.
Well fed.
We do. And of course we want that. And that's one reason why I think that's such an attractive option is because, yes, we all love our beaches here. And we want to have good, well-fed beaches that aren't disappearing all the time. But there are all kinds of other things that, and we referred to some of them earlier. You can use it as, I guess, a ground cover and literally sort of spread it across the surface to inhibit weed growth. And I guess that's been done in some places.
Yeah, people actually buy nice bags of pretty looking gravel from the mainland. You can buy that at the hardware store and use it as ground cover. So, and actually we have a picture here somewhere, but a photo of it, and it's used as ground cover.
Yeah, yeah.
And it is nice looking, and it's not sharp. You can walk on it barefoot.
And in the same way, you can use it actually to help give some soils a better texture.
Better texture for a particular crop.
Yeah. Yeah. If you have a heavy clay soil, putting some of that 3/8 inch, 3/8 minus what you called, mixing some of that on in, it's going to help break it up, loosen it up, make it easier for roots to grow into it and all. Yeah.
And it also used in agriculture just around certain crops because allegedly certain pests won't cross it. And they just don't want to. Like, for example, I heard centipedes don't like to.
Oh, interesting. Interesting. I wonder if it's like the diatomaceous earth being, little tiny particles get into their joints and irritate them and cause trouble.
Maybe, yeah.
Yeah. Huh. Intriguing. That'd be a nice ecological study for somebody to do. But people then use it for sort of what you call non-structural backfill, sort of what you fill in around places, road beds and things.
Well, that would be more structural, but often anywhere that's not going to support a load, and we use an amazing amount of gravel for this purpose, just to fill something next to a wall. You either need to find some soil, or you got to find some gravel. You have to find something to fill the hole, and there's an amazing amount of gravel for that purpose. And that could use all the glass that we produce. Right,
so that's an example of one of these uses that, there's a tremendous potential market. The problem is, of course, it's not very high cost. No one wants to pay very much for that stuff, right?
Yeah, at the moment, you don't have to pay very much.
Right. So a lot of this it's a very dynamic thing, right? When you're taking all those different factors and looking at them but it's all changing steadily as our supplies for certain commodities drop. Prices of energy may fluctuate. As our building patterns change, different uses may come more to the front. You know.
Exactly. I was reading just incidentally that, for example, one of the quarries in Oahu was having trouble permitting, and they weren't quarrying here. And then at that time, they had to bring it in from the mainland. That must have been some expensive gravel.
Yeah. I would think.
Maybe it would be more competitive. I mean, glass would be more competitive at that point if we reach that point again.
Right. But again, there are weird laws and policies about where you can or can't use glass gravel instead of ordinary gravel, depending upon some uses, I suspect, right?
Yeah, there's there's a big perception, and it's understandable, that glass is dangerous. Broken glass is dangerous.
Right.
Pulverized glass is not.
Right, yeah. Some of this we have to just get people thinking more reasonably about all this stuff, right? And understanding what the real issues are here.
Yeah, that's what we need to do, yes.
So one of the very intriguing ones was this filtration media, where I think the stuff really, glass has real potential, right? Again, when you ground it down to this 3/8 minus or even finer, because you're processing it from a fairly large scale down to a small scale, you can get a very consistent grade of material then, right?
Yes, exactly. Because you're already processing it, you can get this material. And right now, it's quartz sand that's processed in the same way, natural sand from the mainland. And so it's a very expensive product. And so it would compete directly with it. I mean, it could replace quartz sand.
Right, but the problem there is there's not that much of it needed, a few thousand tons a year at most, right?
It won't really solve our problem of getting rid of 23,000 tons plus.
Right, it'll take 2,000 or 3,000 tons away, which is nice, but and we'll do it in an economically feasible fashion. But so again, this is one of these great examples of a social problem. There's not one neat solution. There's a bunch of little semi-solutions, none of which is perfect, each of which may have a part in the overall scheme of things, right? And we have to, as a culture, be flexible enough to look at all these different options and think about what's the best combination to use.
Yes.
Right. So then it's sort of similar to blast media. People want basically sandblast stuff to paint off of surfaces and things. And again, a finely ground up processed glass can be very good for that because it's nice, it's uniform, it's not going to screw up your machinery.
It works well, and you can actually buy it on the market. You can, if you're a blaster, let's call them, you can buy a sack of it at the store and use it. But it's a matter of preference, and it's a matter of what you're blasting.
Right.
There's a lot of things. Like the biggest use in Hawaii is, of course, the shipyards, Pearl Harbor. And they're blasting steel and aluminum. And they actually prefer not to use. They don't use silica, sand, or glass.
Oh, really? So, I mean, this is a little sideline, but why not? What's wrong with silica or sand or glass?
Because one reason is they want to reuse it. Because especially when you're doing a ship with special paints with metals in it, you want to catch everything.
Reprocess the whole thing. Okay.
Yeah. And the other is you don't want to use something too abrasive on aluminum, for example.
Right.
Well, you're going to be wearing out your ship.
Yeah, right.
You don't want to take the metal off as well.
Well, that's true. Now, yeah. Huh. Okay. Interesting. We'll learn something new every day here on the show. Yeah. And then you've got other things you mentioned were flowable fill. Now, what is flowable fill? That's an interesting term.
It's a low-strength concrete.
Low-strength concrete.
And just think for example, when they're digging a trench in a road.
Okay.
And putting a pipeline in, they want to be fast. But if you were to put soil back in, you need to tamp that soil down, compact the soil.
Right.
And you need to do it carefully.
Okay.
It's not fast. Because it has to be done by a person, essentially. A trench is only 3 feet wide or something.
Right.
So, and generally they want to get these holes covered up and the road back in use that day.
Okay.
So flowable fill is a low-strength concrete that you could actually break with a shovel, but you can just pour into the hole.
Okay. Interesting. Okay.
And the reason it could work is glass interacts with cement in a negative fashion.
Negative fashion.
And creates weak concrete, let's say.
Okay. I see.
There's chemistry behind it. But if you already want weak concrete,
right.
And we're talking very weak concrete.
Right, yeah. Huh, interesting.
That you can hit with a shovel and break, then it's okay.
And then sort of last but not least on the list was glass fault. That is essentially putting glass into asphalt, more or less. Which people, again, I think there's more almost an emotional resistance that we don't want, glass in our roads, right? That seems counterintuitive, right?
Yeah, and in our interview process and talking to people, industry is very resistant to it. The users are very resistant to it. It's been tried a lot in the mainland and used.
Yeah.
New York City has lots of roads, and many other cities.
Huh.
And Hawaii has a few. It works fine, but it's probably, let's just say it's a complicated way of landfilling the stuff.
Sure. Sure.
There's a lot of mechanics in the back of this. It makes things much harder making asphalt.
Sure.
And an interesting thing we found that it hurts is most asphalt is recycled.
Oh, yes.
When they rip up a road, they take that stuff back to the plant,
Right.
cook it, and remake it into asphalt.
And you- with the
But
glass-
when it has glass in it, they don't want to.
They don't want to, they can't.
I think there's just rules about doing this. At the moment, they can't. If they
Interesting.
do it, the whole batch is contaminated and they have to throw it away.
So once again, we come back to this whole policies and laws sort of almost getting in our way here.
So if we did it now, it would actually hurt the environment because
Because we end up more landfill and...
we have a lot of waste asphalt to get rid of.
So this is really intriguing. I mean, this is really, it's been a rich conversation here because it's really shown me, and I hope our audience, that there aren't any really neat, clean, simple ways through this. This is oddly a morass of interesting, intersecting needs, constraints, pressures from the environment, from the health world, from economic forces, all sort of overlaid with a meshwork of policies, legal issues that constrain and shape all this. So here's our takeaway message, I guess, is that we should indeed try to use glass at the highest level always whenever possible, and keep it out of the out of our environment, except in sort of controlled ways, right?
Doing this study made me very aware of that.
Yeah.
I've started doing making my own peppers and pickles because I eat a lot of those, and it comes in a glass jar. And you really can't reuse. I mean, what do you do with that jar? But if you make your own, which is perfectly good, you can keep reusing it.
That's right. So, anyhow, so what is I guess your advice then for people here in Hawaii about glass?
Two things. I would think use less glass.
Okay.
Really think of what you're using. And the other is start thinking of reuse options. We should really think of that.
I like it.
Having standardized beer containers, for example.
Right.
Beer could be made in Hawaii quite a bit.
Yeah.
And soda is, for example, and both of those.
And there's no real reason we couldn't have, yes, as you say, standardized bottles that just get just reused from beer to beer to beer, and wine to wine to wine,
And I think it's a time we return to that. Yeah.
Exactly. All right, well, this is great. This has been a very rich discussion. I've really enjoyed having you back here on the show again, and I thank you for your time and for your good insights that you've provided. I hope our audience has enjoyed this. It's been an interesting discussion about the complexities of recycling glass. So that's it for Lakeable Science for another week. I hope you'll join us next week. I'm Ethan Allen. Thank you, Kevin.
You're welcome.
Aloha.